A brief introduction to logistic. Keep in mind, logistic model can be used for multi-class classification also. Now I have shown you only binary classification here. You will find these pros and cons about logistic, many other models. Make no assumption about the underlying distribution. This kind of you have to take with a pinch of salt. This is not really true in my opinion. Can be used for multi-class classifications. You can print out the probability values for each class. Given a query point, given an income, what is the probability belongs to default or non-default? You can print out the probabilities also. Many people like that instead of class. Related to other algorithms, one of them which I'm going to talk about, k nearest neighbors and all, related to other algorithms, this is quick to train. And when the incoming test record comes in, it's quick to classify also. When you have simple data sets means dimensions which have clean classification, linearly segregating data points, then it gives you good results. But as you saw, as long as you go with the default resistant to overfitting, but then even this can be regularized, we can control this also. All models can go to overfitting. And by the way, if you have any outliers, even this will fall on its face. Because inside this algorithm is linear model. Linear models are all impacted by outliers. If you print out the coefficients, then you can make it, you won't be able to directly interpret this as we did in linear model, but some people claim that this can be done. Disadvantage of this logistic model is, again, the way it cuts your mathematical space into boundaries. Since it uses underlying linear surface, that is a limitation. What exactly does that mean? We'll see that when we do decision trees. In multi-class classification also, this will be one versus the others. I have no problem. For example, Facebook's image recognition, the algorithm runs continuously for 6 weeks non-stop before it learns to identify the images, right? But when it comes to quickly identifying on the fly a particular person, it takes no time. So training time or test time, it depends on that. So if it takes long time in training, it's okay. But if it takes long time in the production environment, then it's not okay. Recalibration, that's what we do. But you can't do incremental training in the sense, because your training data has to be a true representation of the real world where it's going to run. I might have gone back and what is called feature engineering. I might have gone back and extracted some new columns out of these columns and rebuild the models. For classification, these are the ones we use. Recall and precision are the most important ones. And if my distribution of the target classes is skewed, I never look at overall accuracy. That will completely mislead you. So you have to look at class level accuracy and class level precision. There are other methods like geometric mean and all, which I'm not